Hello, space fans. We are back as usual on our every 2 week stint. Terry Moseley and I. How are you doing, Terry?
I'm fine, Nick. Hope you too.
Good. Anyone who's a fan of Laksh and is asking why is Laksh not here, Laksh's birthday is today, so he's got the night off, and we all wish him a very, very happy birthday. 21 again, we believe, Laksh. We were trying to work out if Terry and I's combined age was probably about 10 times that of Laksh before. But no, really, really happy birthday, and yeah, I hope you have a great time. It's been a busy few weeks for us, and we were kind of planning this a few days ago. We was kind of get some plans in place a few days in advance, and then in the last 24 hours, something rather big happened in space and kind of broke the internet in some respects. So we're going to be talking about that. We've got quite a few good stories across the board. Obviously, we're going to try and do a mix of what's happening in space science and launch systems and human spaceflight, etc., along with the astrophysics and the space element of this, and also our big look-up thing at the end. This is our penultimate show of the year as well. We've got one more in 2 weeks' time. Then we're going to be taking a break over Christmas back in January. So please tune in for the next one on the 30th of November, which will be our last one of the year, which will be a big roundup. And we always have a lot of fun with that one anyway. So moving on to our first and big story. Even if you're not a space fan, you've probably heard about this. I had various members of my family calling me up and saying, what the heck's happening up in space? As you probably know, we talk about space debris a lot on this show because it is a really, really important thing. The impacts that space debris has on astronomy, astrophysics, scientific research, on launch systems, on Earth monitoring. We've just come out of the COP26 climate talks in Glasgow, and the impact of how many degrees the planet's going to warm up has not escaped anybody. And a lot of the monitoring of that relies on satellites, and a lot of our infrastructure relies on satellites, communications, shipping, navigation, all sorts of things. So we kind of have a bit of a bugbear, well, I do in particular, about people like Elon Musk with Starlink. Whilst he's doing great stuff with his own launch systems with Starship, etc. We've always said this, really, really fantastic. Starlink is a real problem. Growing number of satellites. We're looking at FCC filing data this week. From all accounts, it looks like there's filings being made for 94,000 satellites to be in orbit within the next 10 to 20 years. Now, given that there are currently 4,550 active satellites in orbit, and around about anywhere between 131 million and 178 million pieces of debris, that's a lot of a problem growing. And whilst this is an exponentially growing problem that everybody is kind of becoming more and more aware of, this week something happened which brought this very much into the public spotlight. Our lovely friends over in Russia. Now, the Russian space agency, Roscosmos, again, they do fantastic things. They've been delivering, cosmonauts and astronauts and people, even Britain's Tim Peake, up to the International Space Station for a long time. Some of the most fantastic launch systems and reliable launch systems ever developed. Obviously, during the 1970s, they had the Venera program, did some fantastic work on Venus and Venusian surface. We're not having a go at the Russian space program. We're having a go at the Russian space weaponization program, which appears to be gaining pace. Between what's happening in the Ukraine, if you've not seen the news, Russia are amassing tens of thousands, if not hundreds of thousands of troops on the Ukraine border. There's all sorts of issues in Eastern Europe, Belarus, etc. But this was the big one from our perspective in terms of space. So this week, Russia decided to blow up a satellite in orbit using a surface-launched missile system. This was an A235PL-19 Nudol ASAT system, which launched out of Russian territory, flew up into a reasonably low Earth orbit. I say reasonably low, it's 485 kilometers. So round about the altitude of the International Space Station, funnily enough. And they decided to wipe out a 1,750 kilogram satellite. Now, they're not the first country to do this. We've got to play fair here and say, the first country to actually do this with the United States, and there was international condemnation over that. It was a really stupid thing, and America kind of took a major slap on the wrist, and they're not going to do it again. Then China launched one, and they did their own ASAT test, and again, that got international condemnation. And a few years ago, India decided to do one, and that got massive amounts of international condemnation, and India were trying to defend it. And I remember having running battles with some of the Indian armed forces over this. It was really quite bad, literally running battles via social media, where they were saying one thing and I was basically proving them wrong. Some of the debris from that is still in orbit and at very, very high altitudes. And this is the thing, when you hit something, it kind of obliterates in every direction. So what's happened is this ASAT test basically hit a satellite that the Russians launched when they were still the Soviet Union in the early 1980s. It's called Cosmos 1408, and this is what's called an ELINT satellite. So this is a signals intelligence kind of surveillance satellite. And a couple of days ago, day or so ago, confirmation comes through that this thing had fragmented. And for a while, the Pentagon and various other people weren't saying much about a lot of space science and on the ground tracking capabilities. Companies like Leo Labs, Norse, etc., were saying this is an explosion. This is a catastrophic explosion. And it came to light that it was this ASAT test. Now, when I say catastrophic explosion, the initial tracking data coming out of this is showing that it's broken up into over 1,560 trackable pieces. The information coming out of the Pentagon, that was basically, they did a big press conference, indicates that there are hundreds of thousands of smaller pieces that have come off this satellite. The Indian ASAT test was a much smaller collision, much smaller satellite. This is a huge, relatively huge satellite. 1,750 kilograms is a significant satellite. You hit that, it's going to create an unholy mess. What then transpired is, because of the orbit, its orbit intersects that of the International Space Station. So the ISS astronauts had a rather ominous wake-up call, basically telling them, batten down the hatches, literally batten down the hatches, and get into your escape modules, as it were, i.e. the spacecraft, potentially the Dragon, etc., because you could be coming back to Earth. NASA's ground communications are saying that the possibility was relatively slim, but it was definitely there. And it was almost like watching the movie Gravity unfurl for real. It was literally like, this is actually happening. They're not out of the woods yet. There are still pieces zipping by every 90 minutes. The threat is increasing, if anything, because, as many of the commentators are saying, people like Jonathan McDowell, as I said, Norse, the really, really good high-end space tracking, space situational awareness people are saying, these tiny pieces, don't forget these tiny pieces, which could be maybe a few centimeters, are still traveling at anywhere in the region of 8 kilometers per second. Now, 8 kilometers a second, the kinetic energy of even something that small is enough to go straight through the cupola, for example, on the ISS, and could cause significant damage. There's going to be no EVAs, I would imagine, for a considerable while now, while they ascertain what the actual threat is, because the threat is real. It is intersecting the ISS orbit, and also the Chinese space station's orbit. So, and as this stuff decays, it will be uncontrolled. It'll be an uncontrolled decay from anywhere between 440 to 520 kilometer orbit. So it's not going to decay quickly. This could potentially be up there for decades and just drifting around, untrackable in many cases, and drifting down, gravity, etc., will pull it back down towards Earth. So it will be intersecting other satellites. And as I said at the beginning, we have FCC filings now for 94,000 satellites. So the collision risk just went up a whole set of notches, not even a notch. It's really bad. The impact on astronomy is probably minimal in this case because they are very small debris pieces. The impact on human spaceflight could be literally catastrophic. And you've got to ask the question, does it need somebody to die before anybody pays any attention? We've had strongly worded, and I love that term, strongly worded comments from everyone from Astroscale, who recently conducted the LCD experiment in space, where they basically sent up a mission to try and show how you could remove debris. That mission was hacked into. We won't go into any details, but it was hacked into. So, there's some nefarious people out there anyway. But on top of that, you've got the, NATO, United Nations, the US State Department, etc., all condemning this. But what are they going to do? Because at the moment, as I said, the Russian Federation are massing troops on the Ukrainian border. They are apparently involved in what's happening in Belarus, on the Belarus-Poland border. And now this. So you've got to ask yourself, do they really care? I don't know, Terry, I don't want to go into too much politics, but your thoughts on this?
Yeah, I totally agree with you. What's so worrying is that the pieces that they can track, they can obviously move the ISS out of the way. And if an ordinary unmanned satellite, uncrewed satellite gets damaged, it can be replaced and so on. But I'm not sure whether the tracking station tell us the full story, but I believe they can track anything down to about the size of a pack of playing cards, something like that.
About 5 centimeters tracking.
Yeah. Below that, you have pieces the size of, say, a matchbox or a sugar cube. Something like that hitting the ISS, as you have said, it's going to go straight through it. I mean, it is madness. The Russian crew up on the ISS, it's not just all Europeans and Americans and Japanese and whoever. I cannot fathom it, other than, as you say, the politics to show they can do it. And if they have political aims in Ukraine or wherever, we're letting you know that if you try and interfere, this is what we can do. But I'm straying into pure politics there.
It's worrying.
It's crazy from the point of view of safety.
It's worrying. I mean, you're not going into the politics too much, but the reality is right now, space is dominated by essentially one company, and that's SpaceX. SpaceX have a good quarter of all of the active satellites in orbit right now, pretty much. And obviously that system is based around internet communications. Starlink is all designed to provide, seamless internet coverage all over the world. And if you've got nation states like China and Russia who literally want to stop people accessing free information, which may be against their political will, for want of a better term, then what do you do about it? Because Russia have no imminent plans for a big constellation launch. China have filed, potentially a 13,200 satellite constellation of their own. But right now it's not in orbit. Russia don't have a space station of their own in orbit. So there's that element. Is it kind of, well, look at what we can do, the catastrophic disruption. But the disruption, don't forget, would also impact the Russians and the Chinese. What's more terrifying is if we had a nation state, like a growing nation state such as North Korea, for example, who have recently done things like submarine-based missile launches and intercontinental ballistic missile tests, etc., and are aiming to launch into space. Make no bones about it. You only have to look at what the Germans were doing in 1945 with the V2. They crossed the Kármán line with the V2 in the mid-1940s. That kind of capability will grow. Science, progresses. People can get this information. They can grow and expand on their capabilities. If you had a nation state that didn't really have a big space presence or a big reliance on space, and they were to do something like this, it's really quite worrying. I'm just adjusting my microphone because I realised I've been told by our wonderful backroom team that it's popping a little bit. But yeah, it's really quite scary. And the impact on space exploration is huge. NASA are about to launch the James Webb Space Telescope. We'll be talking about the Artemis as well in a bit. But there are some really hefty multi-billion-dollar missions aiming to do science or exploration over the coming years. And they've got to punch through this. So we're either going to have to develop space tractors or space plows to get us through it, or something's going to have to change. And it needs to be almost, we've got a moratorium on the use of weapons in space. We've got a moratorium on, a complete ban on the use of weapons of mass destruction in space. But what's a weapon of mass destruction if it's not something that's creating, an inordinate debris cloud that could kill astronauts or could literally wipe out, trillions of dollars worth of communication, etc. And it's not the monetary value, it's the value to Earth observation, to communication, to all the other things that I've said. The impact will be felt by everybody. If we lose space, most of the general public don't realize just how much we rely on space for our everyday living. If we wipe out that capability, we're not going to get fancy pictures from the moon or fancy pictures from Mars or any of the deep space missions. We're going to get nothing. We're going to be back in 1956. So, not good. Putting it nicely. There's no other way of saying it. I'm sorry. It's really quite catastrophic. Anyway, next story is not much happier one, but a little bit more sciencey. Terry.
Yeah. It just occurred to me there that basically this is a new pandemic, and it's not just around the whole Earth or on the surface of the whole Earth, it's around it in space as well. Yes, slightly better news, good news and bad. The bad news first is poor old Hubble Space Telescope. It's now 31 years old. In July, it had a sort of a relatively major shutdown because of problems that I'm not going to go into now. We talked about them at the time. It's now suffered another little mishap. It had a fault with the synchronization of all its internal communications. You don't need to go into that in too much detail, but basically there's a whole lot of internal communication between the pointing, the guidance, the imaging, the telemetry, and all the rest of it. And that all needs to be synchronized for the thing to work properly. So that failed. All 5 of the main instruments went into a safe mode, which is what they're designed to do when there's anything like this happens. And of course, the good guys and gals at NASA started looking at the problem and interrogating the system and doing simulations and so on to see what it was. So they think really it is just the problem of a lack of synchronization of the internal comms. They are working on that, and the good news is that they have now got one of the main instruments back again, the advanced camera for surveys, so it's working. And they're still working on bringing the other main instruments back online. And this isn't just a telescope with one instrument on the back. As well as that, it's got the Cosmic Origin Spectrograph, the Wide Field Camera 3, the Space Telescope Imaging System, near-infrared camera, and a multi-object spectrometer. And they all take their turns basically in doing observations and recording data, and then that's sent back to Earth. So it's not just literally one instrument that takes pretty pictures that we see in the media every so often. Huge amount of really good science is being done there. They're being very careful in making sure that whatever they do doesn't make anything worse, but they are hoping to get all of those other instruments back operating again. And it is amazing that they do that remotely with a telescope that was launched 31 years ago and was designed about 40 years ago, and some of the software and hardware in it is that age. And yet, you know, they're coaxing it back into operation again. If I had a computer here on my desk that was that age, I wouldn't be expecting to get it to operate at all. So good luck to the ones at NASA that are working on this. They've fixed it before. I'm hoping they'll fix it again. And until James Webb goes up, which we'll probably talk about next time, this is still our main telescope in space for the sort of astronomy that most people are interested in. There's other stuff in gamma rays and all the rest of it that very useful to professional astronomers, but for the likes of you and me that like looking at nice pictures of whatever's out there in the universe, Hubble is still the one. So let's hope they get it going again.
It's interesting you say that. You think about computers in the old days, and you know the era of the Commodore 64, for example, which some of our listeners may remember if they're of a certain age, and the VIC-20 and the Sinclair, Timex Sinclair ZX80s and 81s, etc. These things all booted from ROMs, so the kind of boot times were significantly faster in many respects, and they were in also many respects far more robust because there weren't as many moving parts in those days. And if you think about it, the Hubble technology is decades old. You know, the ACS Advanced Camera for Surveys and WIFPIC, etc., all of the other cameras on board. These are not modern CCDs as we know them. You know, the average amateur's got more capability in a digital SLR in terms of number of megapixels, etc., than is on the Hubble. But it is this remarkable instrument, and the scientific output is the most prolific scientific instrument pretty much in human history. So it's one to definitely keep alive for as long as possible. And I've no doubt when it eventually does fail, either that reaction wheels, gyros, reaction wheels are the things that obviously stabilize the spacecraft in orbit, and the gyroscopes enable it to do the pointing, and they've managed to do loads of kludges over the years in terms of getting less gyros to still keep it pointing in the right direction. It is amazing what the SDSCI, the Space Telescope Science Institute, have managed to do in keeping this working. But yeah, James Webb is a very different beast, and it's also interesting. We were talking just before we came on air about research papers going back into the early 80s from the IRAS satellite, the infrared astronomical satellite that was an orbiting satellite before the Hubble. And some of the research that's still going on where they think they potentially may have found an extra planet in our solar system from IRAS data going back decades, because as data reduction methods and processing methods improve, and the ability to take old image data and reprocess it improves, we're still getting new science out of this stuff. So Hubble's legacy will go on for decades, no doubt. There'll be research papers coming out of what the Hubble's generated for a long time to come. But we do need to keep it up there. And again, if you've got tons of debris flying around, that's not helpful either. Hubble has had some strikes. There was an incident with one of the solar panels when it was brought down, and they showed that it had been hit by something. So, yes. Anyway, moving on to our next story. It's not a good week, really, for things happening, bad things happening. So, SOFIA is a quite incredible telescope and instrument. I had a great fortune of being on board SOFIA when it visited Germany, one of the European Space Agency events about 10 years ago now. And to go on board this thing is quite amazing. Essentially what it is a modified 747. So whilst the Boeing 747s no longer fly commercial airline passengers, somebody had the brilliant idea of taking the 747 SP and modifying it. So it's a slightly different version of the commercial 747. And inside they managed to put a 106-inch or 2.7 meter telescope. Now you think, hold on, what about turbulence and all the other things? Well, essentially, this telescope is completely isolated from the main airframe of the aircraft. And the pilots are brilliant NASA pilots, of course. And this is a joint project between NASA and the DLR, the German kind of space agency and aircraft group. It is an amazing thing to see. So this telescope is an infrared telescope. SOFIA is basically a stratospheric observatory for infrared astronomy. And why they put an infrared capable telescope on there is because with this thing's ability to fly, it can track objects. So it can move, and basically the flight path enables it to track in multiple axes. So the telescope itself can move up and down. Very limited movement left and right, but the arc that the flight path can go in will enable it to track objects. And they've got auto guiders and various other things that will track onto an object anyway. But essentially, if you're up at 45,000 feet, which is where this plane can get up to, you're above about 99% of the absorbed moisture in our atmosphere. So essentially, all the things that make infrared astronomy really difficult to near on impossible from the ground are very capable from this telescope. And it's wonderful. And again, given what's happening up in space, this should have been a real boon to astronomical observations in the infrared spectrum, because we had the European Space Agency's Herschel spacecraft and the IRAS that I just mentioned earlier, both infrared observatories, both on orbit. But once they ran out of their cryogenic cooling systems, essentially they were dead. They were unable to function. They could work no more. Whereas with this, they just land it, top it up, get it reset, and take off again. And that was the theory. So when this was first proposed about 25, 30 years ago, it was a really ingenious and brilliant idea. But it transpires that it's actually costing about 86 million a year to run for only 1,000 hours of observations. Now that puts it as one of the most expensive astrophysical experiments in the world. NASA have decided, due to various congressional budget cuts, etc., and the decadal survey, and they obviously have this kind of round robin of what we should do and how we should do it and where we should do it. It looks like it's finally met its maker, as it were. There's been plans to cancel this multiple times. It looks like it may finally be hitting its death now, which is a real shame, because it is a very unique observatory, a very unique facility. It'd be great if a consortia or some venture capitalists who seem to be pumping money into Starlink-like projects like Billy O, if they could get behind this and keep it going. I mean, there could be ways of optimizing it, there could be ways of running it in a more efficient way, but I don't want to see this die. Being on it is incredible. It was, as I said, such a privilege. And I know people who've flown on it and people who've been on it, when it's been observing, and they just say it's remarkable. It's very cold because you're in basically the back of a 747 that hasn't got all the comfy seats, etc. It's just got banks of computers, and then you're looking on the telescope towards the back of the aircraft, where you've got a big open hatch, and you're there. And at 45,000 feet, you're potentially you're on oxygen, etc. above 10,000 feet typically. It's probably not comfortable. It's probably not efficient, but it is brilliant. I don't know, Terry, any thoughts on this one?
Yeah, I mean the whole point of the thing was to make it an awful lot cheaper to do observations in the infrared than sending stuff into space. I mean, you have 747s already. You simply modify this one, put the big telescope on the back, and all you're doing is the cost of a flight. But it's not as simple as that. There are a huge number of extra costs, and since the justification for it originally was that it was going to be cheaper than satellites, once that's no longer the case, really, it's just not as good as having a telescope in space where you're above 100% of the moisture in the atmosphere, and you can also observe more or less continuously, not just from one flight to the next. How many hours did you say per year?
It's about 1,000 hours for
Dollars
86
a year.
million.
Yeah. So that's not what a space satellite's capable of. So sad, but economics dictates almost everything now.
Yeah, it's a shame because the science output, when it was generating really good science, it was good science. But I guess everything has its day. But it's just a shame because you've got this and the problems with the Hubble and various other things we're going to be talking about in a moment with Artemis, etc. It's a bit of a woeful week. Anyway, moving on to our next story.
Yeah, this is one that caught my eye. Black holes seem to be in the news almost everywhere. A lot of people watching this will know that there's a supermassive black hole at the center of our galaxy, probably one at the center of most galaxies, certainly the big spirals and ellipticals and so on, maybe not the smaller regular ones. There's also all the stuff that comes in from gravitational wave astronomy now, with black holes merging with each other and black holes merging with neutron stars and so on. So we're getting a fair idea that there's an awful lot of them out there. There are different ways in which they can be formed. There are constraints on how massive they can be, both upper limits and lower limits in terms of how they're formed. So it wasn't all that surprising that we found a black hole of this particular mass. But what is interesting is where it is and how old or how young it is. It's outside our own Milky Way. It's in a very big star cluster called a supercluster in one of the Milky Way's relatively small satellite galaxies, the Large Magellanic Cloud, about 160, 170,000 light years away. And they found one in the middle of this cluster using one of the most powerful telescopes, sort of multiple telescopes on Earth, the Very Large Telescope, imaginatively named, which sits on top of a mountain in Chile. And it's basically 4 large telescopes that can be operated as one. On one of those, they have a unit called the Multi-Unit Spectroscopic Explorer. And what it was able to do was, because this supercluster of stars is so far away, it's relatively small in apparent diameter on the sky, and they were able to observe all the stars in it simultaneously. And they were looking for things that were changing and varying or moving and so on. And to cut a long story short, what they found was a black hole with about 11 masses, solar masses, in orbit with a smaller star, but still bigger than our sun, about 5 solar masses. So these two are orbiting each other. And not all that many black holes of that sort of range of masses are known. Most of the ones that we detect, for obvious reasons, are bigger, because the bigger they are, the easier they are to detect. We don't see them directly. We detect them from either gravitational waves or their gravitational pull on whatever they're orbiting and so on. But the interesting thing from the both sort of cosmology and astrophysical aspect is the star cluster is only thought to be about 100 million years old. That's older even than me, but it's very young in terms of the age of the universe, which is about 13.8 billion years. So this is one of the youngest of these big superstar clusters with thousands of stars in it, probably about 40,000 solar masses altogether in the cluster. Not all the stars are as big as this one. A whole lot of them will be smaller. So how does a black hole form so early in the life of a star cluster? Does it form from a supermassive star coming to the end of its life and shrinking into a black hole? Is it the merger of 2 other objects? Is it the result of a different sort of supernova explosion? Basically, we don't know at this stage just how a black hole of a mass of 11 solar masses could form in a star cluster as young as that. So black holes they're intriguing objects. They're great popularity in science fiction stories and films and so on. They are there, and we're learning a lot about them. So this one is a new one. It's throwing up a lot of questions still to be answered. And the main one is basically, how does a black hole of that size form in a star cluster that is so young? So have you any thoughts on it, Nick?
It's interesting. It kind of reminds me when I was working on some large telescopes some years ago, the Fox telescopes, which are 2-meter size of the Hubble telescopes, and about 6 years working on observations, mostly of comets. But I got involved in a project to observe a star cluster called Westerland 1, which contains one of the largest hypergiant stars known, Westerland 126, which is just this enormous star system. And the analogy was always the James Deans of the star of the star world, as it were, the live fast, die young. And this has always been the thing with supermassive star clusters. They burn really bright really quickly, and then kind of will go poof. And obviously we know stars above a certain mass will turn into black holes, neutron stars, etc., etc. It's interesting because there's also analogies with what's being observed at the edge of the observable universe as well, in terms of the kind of the dark ages period just after the Big Bang, and some of the observations that are being theorized and some of the hints that are coming from there. With galactic formation, it could really disrupt our whole modeling of how galaxies form and the duration of how galaxies form, and how you can get from essentially a Big Bang event occurring to potentially only a few 100 million years later having galaxies and black holes forming, which it's not been proven yet, but hopefully when things like the James Webb Space Telescope and the Square Kilometre Array come online, they're going to be able to peer back even further than the Hubble's been able to with things like the Hubble Ultra Deep Field. I find this really fascinating because it proves yet again that we really don't know everything out there. We keep coming up with new stuff and keep thinking, well, yeah, we've got a handle on this now, and then you have to throw in dark energy, and then you have to throw in dark matter, and then you have to throw it. It's a never-ending, evolving story, space. And space science, this is why it's so important. We need to retain this capability. And if what's happening in Leo happens, we won't be able to observe from the ground because there'll be such a mess in front of us, and we won't be able to launch any spacecraft to observe from further out because we won't be able to launch them. Anyway, cracking story. I love this one, and it's kind of got me thinking about digging out the old Westerland 1 notes and the observations we're doing on that. Really fantastic star cluster Westerland 1. If you ever get a chance to do any professional observations on that, really in the infrared you need to go, because it's kind of a bit obscured in the optical. But anyway, moving on to our next story. This is another big one and another bad one. Well, it's not bad. It kind of wasn't that unexpected. So Artemis is the sister of Apollo, and so named because we're now almost 50 years on from Apollo 12. 52 years on from Apollo 12 and 50 years on from the last Apollo missions, Apollo 17 in 1972. So 52 years this week. Apollo 12 was on its way to the moon and landing on the moon, and Pete Conrad and Alan Bean were doing their fantastic stuff, and Dick Gordon in orbit. So there was always a big kind of, why haven't we been back? And then, it was all decided that we were going to go back to the moon. And Artemis and the Space Launch System, the SLS, which is the gigantic vehicle that's going to get us back to the moon, the Trump administration had said, we're going to go back to the moon by 2024. And that was probably political because Trump was expecting to get in for a second term, and he wanted to be the president like Kennedy to announce something huge, and then it occurs during his presidency. So it didn't happen, didn't transpire as he wanted. It now looks like that 2024 goal, which everyone in the engineering space science community said, no, it's not going to happen, is not going to happen. Bill Nelson, who's the current NASA administrator, basically said it's delayed, and the earliest we're looking at now for Artemis 1, which is going to be the first test flight with no crew on board, potentially still on for next year. That could slip, we don't know. The first crewed mission, which is going to be basically a rehash of Apollo 8. They're going to circumnavigate the moon, potentially go into orbit a few times, come back, who knows, and go further than any humans have ever been. They're aiming to go about 40,000 miles further on from the lunar surface on the other side, as it were, and then come back. So it will be the deepest space mission ever achieved by humans. That's going to be probably now maybe 2024, and then they're now saying the landing could be 2025. Optimistically, I think they're still too optimistic. I think the reality is, between all the different systems, and the Orion spacecraft, that's been ready for quite some time now, the crew capsule and the service module, which has been provided by the European Space Agency, they're pretty much done. And Orion has got a budget boost in its own right. So Orion was originally slated for about $6.7 billion worth of budget. You think about the staggering cost of this. And we'll go into the costs a bit more in a minute, because they are eye-watering, these costs. So Orion's got a budget now from 6.7 up to over $9 billion, which is really good. Lockheed Martin will be very happy about that, because they're the main prime contractors for this. Boeing, on the other hand, massively overrunning, massive delays, and it looks like these delays and cost overruns are hitting NASA quite hard now, because congressional budgets were really assigned to go beyond the first couple of Artemis missions. And looking at the launch costs against the vehicle, so SLS is going to come like Apollo did, like the Saturn V did, in various what they call block configurations. So the SLS Block 1, which is a crew transport vehicle capable of lifting about 95 tons up into orbit and 27 tons for translunar injection, which is great. But the estimated launch costs are around about $2 billion per launch. Now, if you compare that to the estimated costs, and these are just estimated at the moment, obviously these are the goals, but Starship's HLS configuration, which is the heavy launch configuration CLPS payload, which is capable of launching anywhere between 100 to 150 tons to LEO, that's $2 million per launch, because it's a fully reusable spacecraft. Whereas Artemis is not reusable. It's a one shot, up you go, and thanks very much, and so long, and thanks for all the fish. It's absolutely astronomical. I mean, the SLS is going to be around about the same size in the initial configuration, a little bit smaller than Saturn V, and then will grow bigger and bigger. And then eventually you're going to have one of Elon Musk's Starships stacked on the top of it, which is going to form the basis of a lunar landing system. Between the lunar lander itself, the overruns, the mission configuration, the fact that the spacesuits are still having issues, that we've got delays, the whole issue of Jeff Bezos and Blue Origin suing NASA because they were shut out of the contracts, because Congress had said we couldn't have multiple contractors, even though in Apollo they did. The costs are getting literally eye-watering now. So they're estimating anywhere between about $90 to $93 billion, which is still cost adjusted less than Apollo, to be fair. But Apollo was the entire Apollo program. The entire Apollo program, cost adjusted, is around about $120 billion. If you take 1960s to early 1970s dollars and translate them to now, and the cost, increments, etc. And with very limited computing power, very limited capabilities, etc. Never been done before. Complete program, going from Apollo 7 low Earth orbit, and 8 going to the moon, 9 low Earth orbit, and 10 going to the moon, 11 going to the moon, 12, all the various missions up to 17. The entire cost is only a fraction more, only a little bit more than what they're slating now for just the first part of the Artemis missions. And then they've got to build the Lunar Gateway, and there's so much in this. And it's great to see. It's great to see real exploration again. It always irks me when people say expedition this and expedition that. Yeah, we're a couple hundred miles up. The ISS, it's a fantastic orbiting laboratory, and there are some wonderful people who've flown on the ISS. Please don't get me wrong on that one, but it's not exploration in the true sense of the word, which is what we were doing with Apollo, going 240,000 miles away from the Earth rather than 250 miles away from the Earth. So it's just a bit. Seeing it delayed again, I don't know, Terry. You almost think, why are they carrying on when Starship is, and much as I hate what Musk is doing with, Starlink, etc., Starship is remarkable. The cost efficiencies of the Falcons and the Falcon Heavy, etc., are so intense compared to this. It's almost like, why are they carrying on? I don't know.
Yeah, I think they're committed to it now, but I think in the long-term future, what Elon Musk is doing is the way forward. You have to reuse as much as possible. Just one angle, in case people aren't aware, the court has actually, through our American court system, has actually thrown out Blue Origin's challenge on the lawsuit that they should be allowed to be in on the game as well. So that was one of the major things holding it up. That's now out of the way, but that was partly responsible for the delays. So they're too far down the road now, I think, to cancel it now. But I think in the longer term, as you say, if Elon Musk can do it for so much less money, and also better in principle to be using reusable stuff rather than just the money. So that's the way forward.
Yeah, absolutely. Nice comments we're getting in the chat channel, the ground-based space, saying hoping something can be done with Hubble. Yes, completely agree. We've talked about this in the past. This is to ground-based space in particular, who's one of our regular listeners. Thank you very much. And we know we've got some regular listeners. We've got a lot of people who listen on catch-up as well, so I get comments all through the week about, oh, did you say this? And yada, yada, yada. The Hubble. I've always wanted, if they can't save it and put it into a higher orbit and boost it, don't let it splash down into the Pacific, because I think every astronomer on the planet will just burst into tears. It's been such a wonderful thing. And I've always said that if SpaceX want to redeem themselves to the wider space science community versus what they've been doing, with Starlink and disrupting radio astronomy and optical astronomy, then sending up the angry alligator version of the Starship to capture the Hubble, much as in the old days when we had the space shuttle, they could basically pull the Hubble almost into the cargo bay or tether it with the Canadarm, etc. It was it was launched in the cargo bay of the space shuttle. It was the space shuttle's single greatest achievement. If you listen to people like John Young, the astronaut on Apollo 16, who always said that Hubble's greatest achievement, the space shuttle's greatest achievement was the Hubble. If they could bring it down, if it's not recoverable, if the technology is literally too out of date or there's too many issues to resolve, bring it down, put it in the Smithsonian, watch the queues. It would make the term blockbuster, which was coined from Jaws, I believe, in 1975-76, or Star Wars in 1976-77. It would make those look trivial. The queues to see that thing, would be just enormous. I personally would fly to New York just to see it. It's one of those amazing instruments. So hopefully, I agree. Ground-based space. We'd all love to see it brought down. Totally agree with that. But anyway, any thoughts? Any other thoughts?
At the very least, they don't have the technology, or they will have the technology, but they don't have the spacecraft flyable to bring it down at the moment. But at the very least, put it up into a higher, safer orbit until they can do something to bring it back down. Put it up another 50, 100 kilometers, and it'll be safe there for quite a while. And then eventually bring it back down and have it as in the Smithsonian or wherever. In my backyard, I'd be quite happy.
But if you look at Dragon and you look at the Falcons, you look at the docking capability, they know they've got a docking ring now, or they've got a capture ring on the Hubble. And they know that the precision capabilities of the Dragon capsule in terms of autonomous flying, it could get close to the Hubble. We know that. Fuel boost, slight modifications, it could probably do that. With Starship, because you've got such a gigantic fairing, now the fairing's typically what contains the launch vehicle inside the rocket. So the top of the rocket, essentially what happens when a rocket takes off, it'll burn off its fuel. In many cases, it's 80-90+% of the total mass of the rocket is the fuel. That will then burn off, and then you've got basically the main part of the rocket, which will be put into orbit via second stage, third stage, whichever, but typically a second stage, put it into orbit. And then what happens is the fairing, which is kind of like the enclosure that holds the spacecraft safely and protects it from, all the atmospheric drag, max Q, etc., will separate and kind of blow apart. That'll drop that down to Earth mostly. Doesn't always happen. Splash into the ocean, drop to the bottom of the Pacific or Atlantic, and away you go. If you could modify that, and if you've seen the James Bond movie You Only Live Twice, you'd have seen this thing, or the Agena spacecraft during the Gemini program, where they have what's called the angry alligator. We've got almost like this split fairing kind of that shape that could capture it. This is not beyond Elon Musk. The guy is, for want of a better term, a flawed genius, but a genius nonetheless. He's delivering incredible stuff in one respect and awful stuff in the other. It can be done. There is no doubt. So if we could boost the Hubble, just send up a simple, almost like a drone, autonomous drone, to boost it into a much higher orbit until that configuration can be figured out. Or, as I said, possibly upgrade again. The Hubble was always designed to be upgradable. The gyros, the positioning systems, the reaction wheels, the cameras, everything on the Hubble is upgradable. The solar panels even. You could modify it, and it's still a perfectly brilliant instrument. The optics on it with CoStar are astonishing. We proved that time and time and time and time again with these amazing images. So, In answer to your question, ground-based space, yes, I hope so too.
Off the top of my head, I think the mass of the HST is about 11 tons. I'm not sure if they yet have the capability to bring that back down, plus the rest of the rocket and the fairing, and have it nice and waterproof and get it to splash down in the ocean. You need some pretty big parachutes for that. Could be done, but they can't do it at the moment. Yeah,
could be done. I mean, it's interesting. You look at the thinking of being able to re-land Starship, and obviously not with an 11-ton cargo mass, but
yeah,
if you could deploy it through most of the atmosphere, and then, like you said, you are talking about gigantic parachutes. But even if it hit the ground not too hard, but hard enough that it didn't completely disintegrate, at least it's giving it a fighting chance. I don't know.
Yeah.
You've got to take off the solar panels and all. Anyway.
Yeah.
Moving on,
Right.
What's happening in the world of diamonds, Terry?
Yes, indeed. This is much closer to home. Not entirely at home. In fact, deep beneath the surface of the Earth is where the story starts. Diamonds are a girl's best friend, and we all know roughly what they're like, even if we can't afford the big ones. They're formed we thought anyway, in the upper mantle of the Earth's crust, which is the part below the relatively solid crust that we live on. You have the upper mantle, then the lower mantle, which is sort of semi-fluid, semi-solid, sort of plastic, not plastic in terms of its chemical composition, but plastic in that it can move and change shape and so on. Then inside that, you have a molten core. So that's mainly iron and nickel. So what they have found in a meteorite not a meteorite, your favorite subject, a diamond in Botswana in southern continent of Africa, is a diamond that was formed in the Earth. We'll talk a little bit more about that in a moment, with a very rare mineral, what they thought could never actually exist on the surface of the Earth. It's called, on a new name because it's a totally new mineral, whereas a Dave Mayoite, after a very prominent geologist, Dave Mayo. Now, they had predicted that this would exist deep down in the Earth because it can only exist under conditions of extreme pressure and high temperature, which is what you get down there. They have now found it in a diamond on the surface of the Earth, and that was completely unexpected. It's a calcium silicate perovskite, and it's slightly different from another mineral that some people who are interested in geology may have heard of, called wollastonite, but it is formed at a much higher temperature and pressure. And as I say, they thought it could not exist on the Earth's surface because if it was brought up by tectonic or volcanic activity or any form of plate tectonic movement, they thought that it would disintegrate because of the reduction in pressure and temperature. But because this particular mineral, which consists of little black specks of material inside a meteorite, you can see them there in the photograph, the diamond is solid enough and tough enough to have kept them intact as they were brought up towards the surface of the Earth, where obviously the temperature and the pressure are an awful lot lower. So the whole lot of interesting things on that. First of all, it is literally the first discovery of this particular mineral, actually, apart from theorizing it, to actually get it on the surface of the Earth. They have a specimen there that they can study. But because it was formed so low down in the Earth's, as I say, the mantle, it has changed our perception, our understanding of where diamonds are formed. We didn't think that diamonds were actually formed as deep down as that, but obviously this one has. Now, I have to admit, I am even less of a geologist than I am an astronomer. So this is stretching my knowledge to the limit, but it just shows you, even on our own planet Earth that we think we know so well, we're still finding out interesting stuff at what goes on down beneath our feet. Nick, what do you think about diamonds?
It's interesting. I mean, you mentioned meteorites. I've actually got one as a kind of prop that I thought this is a good story. So this is a piece of a meteorite called Sericho, which fell in Kenya a few years ago, was discovered in Kenya a few years ago. And it's what's called a palisade group. So I don't know if you can see that, but essentially what you've got, if you slice this open, it just looks like a normal rock kind of on the outside. But when you slice them open, the palisade groups, they contain this kind of matrix of the metals, but also it kind of encapsulated in it, almost like a dough mixture, as it were, that's gone hard. You've got gem quality olivine in some of them. So you've got basically peridot, if you're familiar with peridot as a kind of ring, for rings and jewelry, etc., crystals in this. These are formed typically in a very kind of thin boundary layer on asteroids. So typically on the outer part of the asteroid, you've got the rocky part. On the inner part of the asteroid, or some asteroids in particular, you've got complete metals base throughout, much like the Earth. You could have a metal corner, kind of rocky crust on the outside, but then this thin boundary layer where only 4% of all meteorites fall into this parasite group. They're formed. And what's interesting is, we talk about the impact event that potentially caused the creation or formed the moon in the early history of the Earth. And there's still so much we don't understand. As Terry said, we don't understand so much about the inner geology of our Earth. We've got this, best guess, as it were, and we've got some deep core exploration that shows, what's happening down there. But we've seismology and all sorts of different tests to show what the transmissibility is of the various materials that make up the Earth's kind of core, crust, mantle, etc. But we still are finding new things all the time. And it goes through, we're talking about black holes before and the new stuff that we're finding now. And we're still finding new stuff at the depths of the bottom of our oceans. We're still finding new species on land. We're still finding, new meteorites all the time. We had a fantastic carbonaceous chondrite. Some of those things contain pre-solar grains that, are older than our solar system. They go back 7 or 8 billion years. There's still so much we don't know. So this, I thought, it's not really an astronomy story, but it is, because our planet is part of astronomy. People say, oh, astronomy means nothing to me. You're on a moving space station that's orbiting the sun every 365 days thereabouts. Astronomy is part of all of us. We're flying through the solar system. We'll talk about a meteor shower in a minute. It's one of the things to look out for. We're interacting with space all the time, and this could be, another prime example of, we don't know what happened with the formation of our Earth. We don't know what happened with the collision that formed our moon. There could be any number of reasons, but the research that will go into this, I'm hoping, is going to keep the geology community busy for years. And we were talking just before we came on air as well about one of our fantastic backroom team, as it were, was experienced, or there was an earthquake up in Scotland. You think, this is still such an active planet. And then you go out and look in the night sky and you look at Jupiter and those tiny little dots around it. And one of those tiny little dots is Io, and that's the most volcanically active thing in the entire solar system. So, there's so much. Geology is wonderful. Geology, meteorites in particular. This is the way to touch space. Yep. If you are never going to go into space and you're never going to fly to the moon and whatever, and astronomy is always by proxy. Astronomy is literally, you're looking at objects and you're looking at, even if you're looking at the moon, it's 1.5 seconds ago or thereabouts. If you're looking at a galaxy like the Andromeda galaxy through a telescope, you're looking at the light that started out 2.1 million years ago. Some of the things you're looking at, the dinosaurs were still roaming the Earth when you're looking at them. Meteorites, you're touching space, you're touching astronomy. So that's why I've got a major passion for them. Anyway, moving on to what to see in space, and some really good stuff in the time.
And of course, don't forget our carbonaceous chondrite t-shirts.
We do. We can't have cool t-shirts.
Yeah. A little bit of good news for a change in terms of what's up there in the sky. A number of things are coming up. First of all, the International Space Station, which we have talked about quite a lot, will start a new series of evening passes over the UK and Ireland on the 20th of November, 21st, depending on just where you are. It's always fascinating to watch it. It gets brighter all the time if they add new bits to it, or if there's a spacecraft dock to it, and so on. My favorite website, because it shows you a whole lot of other stuff as well, is above. You can get apps for your smartphone, which will show you just when and where it's visible from wherever you are on the surface of the Earth. At the moment, as I say, it'll be starting a new series of passes in the evening sky. Not go into the details of all the orbital movement that causes it to be visible sometimes in the morning, sometimes in the evening, but evening passes suit most people, so look out for that. Next couple of days, we're coming to the maximum of the Leonid meteor shower. Again, we're talking about meteors. The maximum is on the night of the 17th of the 18th of November. They are famous, amazingly so, for anybody interested in meteors and the sky generally. They produced the greatest meteor storms ever recorded in human history. The last one was in 1966. Unfortunately, it wasn't well seen from the UK, but from the western side of America, they were recording about 150,000 meteors per hour. That's what you call a meteor storm. That only happens periodically. We're in a relatively quiet period at the moment, but even so, the night of the 17th, 18th of November, you should be able to see some Leonid meteors called so that because they appear to come from the direction of Leo. Later in the evening, the constellation of Leo is rising in the east. Now, unfortunately, this year the moon will be nearly full. We'll be coming onto the moon in a moment. That means that you'll only see the brighter meteors, but nevertheless, it's always worth having a look. And coming on to the moon itself, we get a very large partial lunar eclipse on the morning of the 19th of November. It's 98% of an eclipse. In other words, only 2% of the moon will not disappear into the Earth's inner shadow, the umbra. Unfortunately, the moon will be setting as this happens. If you're on the eastern side, and particularly the southeastern side of the UK, it'll only just be going into the shadow by the time the moon sets. The further west and the further northwest you are, the better you'll see it because the moon sets that little bit later then, and it will have moved deeper into the eclipse. So extreme west of Ireland, extreme northwest of Scotland will get a much better view. Now, a little bit of time, you can find this out online, but just to give you an idea of what's going to happen, the moon will enter the Earth's outer faint shadow. Very difficult to see this at 6 a.m. in the morning of the 19th. It will enter the umbra, which is the darkest part of the Earth's shadow, at 7 hours, 18 minutes. The maximum eclipse, when the moon is nearest to being in the middle of the Earth's shadow, say it will miss it, but only just miss it at 2 minutes past 9. And of course, that's daylight. So what's happening is, as the moon is moving into the eclipse, it is setting, the sun is coming up, and you're getting twilight. So it's not going to be all that easy to see. Now, you have maybe read in the press that this will be the longest total eclipse of this century. Wrong. It will only be the longest partial lunar, did I say solar? The longest partial lunar eclipse of this century. Most total eclipses would be longer than it. In fact, the next one that we will see funnily enough, in almost a year time, November of 2022, it'll be 11 minutes longer than this one. And there are others coming up, which will be about 20 or 25 minutes longer. So it's just the longest partial lunar eclipse of the century. But it's something to look out for if you're heading out for work early in the morning, or if you're an early bird and like getting up. You will see that the moon definitely looks a bit odd just before it's setting in the west and northwest on the morning of the 19th. We have to wait a little while before we see another total lunar eclipse anywhere in the UK or Ireland. So have a look for this one. So there are other things in the sky, but those are the main things to look out for in the next week or two.
Yeah, it's fab. And lunar eclipses, the wonderful thing about them is that not only do they prove that the Earth isn't flat and is round, because you can see as the Earth moves across, it also gives us an indication of just how messed up our atmosphere is, because obviously we're getting this refractive capability. Essentially, the moon, the Earth and the sun are in alignment, and when we get a solar eclipse, it's the moon passing in front of the sun, and the distance between the Earth and the moon is 400 times less than the distance between the Earth and the sun, but then the moon is 400 times less than the size of the moon, the sun in terms of diameter. So at the moment, for the next however many thousand years, we're going to get these wonderful, perfect, total and annular eclipses, which are really good. And the longest one this century was in China. That was an amazing thing. I think you were there as well, Terry. It was just one of those incredible. I know you love your eclipse chasing. Interestingly, with the Leonids, what we've got as well right now, due to that wonderful Russian ASAT test, is we could be finding all sorts of junk dropping out the sky. Who knows where it's going to come in from, what the vector is in terms of things coming in, but they are going to come in because when it hit the satellite, bits would have been thrown downwards as well. So as they hit the upper atmosphere, they're going to burn up. And if you think about it, I'm holding a much smaller version of that Ceratron in my hand now. That's a very small version of that Palisite. That's kind of even big for a shooting star. I mean, something
Very
that
big.
big is going to, cause quite a fireball, as it were. I mean, you see those occasionally and they do disintegrate, but you're looking at something about the size of a grain of sand, but it's hitting the atmosphere at tens of thousands of miles an hour. Typically, as we're intercepting the debris field of comets, which is why we get these meteor showers, Perseus being the most famous, etc. And we talked about all sorts throughout the year where we intercept the tail of Comet Halley. Even we can't even see Comet Halley right now because it's way out in the far depths of the solar system on its way back in. Hopefully, I might get to see it in my 90s. I don't know, but it's one of those wonderful things that, if the moon's out of the way and the clouds are out of the way, it's a great free light show. So definitely that, and the lunar eclipse, seeing the moon turn that really deep red color due to dust in our atmosphere and the refraction of that dust, from the sunlight passing through, etc., is really amazing to watch. And as I said, you realize then that yes, the Earth is actually round. So ISS passes, they're going to be fun, because we don't even know what orbit that thing's going to be in over the coming months. And there's a nominal orbit, but it's going to have to move probably quite a few times. So,
well, I checked just before we came on air, and that's the latest prediction. So it's actually come forward by 1 day. So that may well be as a result of the orbital change.
Yeah, that's the thing. They have to boost their orbit, which is a kind of predicted thing. But sometimes they have to change their orbit to dodge debris. So who knows? We could get no ISS passes. We could get an awful lot of very good ones. But a few more comments in the chat. We just got to do a big shout out. Ground-based space. Like I said, this wonderful person is a regular listener. And Kerbal, if you don't know what Kerbal is, Kerbal Space Program is kind of a phenomenally fun way to learn orbital dynamics and how spacecraft work. So it's kind of this game, as it were, where you've got these little green aliens, the Kerbals, as it were, and you build quite complex spacecraft. You have to understand the physics and the science. You can't just throw something together and hope it's going to launch. It's got to actually be put together quite properly, in the correct manner. And Ground-Based Space, a few weeks ago, he mentioned that he built some satellites, some space probes, and he named them after Terry and myself. Now, the update from Ground-Based Space is that the Terry Moseley probe, which he thought might have crashed into Mars, which is called Duna in Kerbal, escaped. It didn't crash into Mars, so much like Comet C 2013 A1 a few years ago, where everyone was going, it's going to hit Mars, it's going to hit Mars, and it didn't. It was a real shame, because we would have loved to have seen that. And apparently the Nick Howes Space Telescope has discovered a new asteroid as well, so which is fun, because I actually did discover quite a few years ago with the Pulse Telescope, and Terry has got an asteroid named after him as well. So it's all good fun, but huge thank you again to Ground-Based Space for that. It's just so nice. It's really nice that people who listen and tune in really do interact with us, and like I said, we get great feedback during the week, and sometimes we get a few people listening, and it's really nice if it's just a few people. Sometimes we get a few tens, dozens, some of the subscribers, it's up to 300, 400 now. We're not going to break the internet, but we really do enjoy doing this, and it's fantastic. We've got a great team. It's fun STEM. We're doing hopefully lots. Space Store are doing great work. Somebody's mentioned as well that Space Store, yes, Space Store have got meteorites. They make a great, very, very unique Christmas gift. Let's put it that way. Like, what did you get me for Christmas? A piece of the moon. And you can legally own pieces of the moon as long as they weren't brought back from the Apollo samples. But I'll let the Space Store team explain that to you if you're interested. We'll be back in 2 weeks for our, as we said, final show of this year, and then we're going to take a break over Christmas, give everyone a well-deserved break back in January. We'll hopefully be doing some new and fun stuff. Our next show, we're going to probably do a big roundup of Terry and my favourite stories of the year, unless anything really serious breaks, which could be the ISS, we don't know. There could be a kind of abort happening on that. We genuinely don't know, and that's the great thing about space. You can't predict it. You can't predict the news in general, but space, you really can't predict it. Betelgeuse could blow up, or could have blown up however many 100 years ago and be a supernova that's as bright as a full moon. We don't know. Anything can happen, as they said in Stingray, in the next half hour, 45 minutes, or an hour as it is tonight. But massive thank you to our team at Space Store. We'll see you again in 2 weeks. Any final words, Terry?
Yeah, just what you're saying about the debris coming down from the blown up satellite is fascinating. But just on that point, it generally moves through the sky a lot slower than a meteor. The Leonids in particular are very fast across the sky. Space debris generally is coming in a lot slower. So if you see something that you can follow across the sky with your eyes, it's probably a piece of space debris coming down. It's also probably, I don't know the orbital inclination of that satellite offhand, but it was probably in near polar orbit. So any bits that are coming down will be traveling roughly north-south or south-north, whereas the Leonids will be coming from the east. But anyway, fascinating. And when we come back in January, I think the number one topic will be the James Webb Telescope, because it will be on its way out to the Lagrange point. Fingers crossed, everything crossed. So
2 weeks of terror.
See you in 2 weeks' time, and we'll update you on whatever is happening then and the best stories of the year. So cheers, everybody.
Cheers all. Take it easy. Bye-bye. Hi, my name's Nick Howes, space enthusiast, author, writer, broadcaster.
Hi, I'm Terry Moseley, past president of the Irish Astronomical Association, lifelong astronomy and space nerd, absolutely fascinated by everything, both man-made and natural up there.
So every 2 weeks, Terry and I give you the latest, hottest news from space and human spaceflight, robotic spaceflight, and what's happening up in the skies. Please tune in to us every fortnight with the space stuff.